It's the strangest idea in all of science.
Nature is really trying to tell us something.
It emerged by accident from bizarre experiments.
Just didn't make any sense.
People were very disturbed by the idea.
Scientists resisted it,
They tried to explain this away.
but a maverick would force them to take it seriously.
A man of brilliance.
Changed everything.
The idea means we live in a giant bubble.
It's hard to believe.
You are just a clone. And 9/11 didn't happen.
This type of thinking, it's unsettling.
Crazy? Sure. But get used to it. You're living in a parallel universe. This man is about to enter a parallel universe. He's walking to work through Grand Central Terminal in New York, when suddenly everything changes. Somehow he slips into another parallel world in which America has been overwhelmed by a terrible disaster. Grand Central has been abandoned, the crowds are gone, and New York is controlled by vigilantes. Then just as inexplicably, he's back home. Or so he thinks.
Meine Damen und Herren, willkommen.
Now he's in another parallel universe, in which the Nazis won the Second World War. America is ruled by a fascist government, and there's a familiar face almost everywhere.
I think these other parallel worlds are just as real as this one here, which means that there also is another world where Germany won World War II, and when you go to Grand Central, you'll see all sorts of paraphernalia there.
For years, parallel universes have been dismissed as crazy speculation. Now, some of the world's most respected scientists claim these other worlds may actually exist.
The reality that we see is only one of an infinite number of realities.
Several completely different directions in physics have led us to this idea of parallel realities.
It sounds like science fiction. But for the people living in each universe, it's as real as our universe is to us.
From the latest thinking about the Big Bang, the birth of the universe, to the nature of subatomic particles, parallel universes are emerging into the scientific limelight. Strange new ways of visualizing them are being developed.
Throw the boat.
And for the first time, startling new discoveries may provide the first physical evidence of their existence.
There are so many other universes besides ours, and they are interacting with us. We are receiving signals as we speak.
So what are parallel worlds like? Could we ever visit? And if we did, who would we find?
There really would be an infinite number of copies of you and me identical to our real selves.
I travel to parallel universes all the time.
Parallel universes used to be the preserve of science fiction. Top physicist Lawrence Krauss was brought up on the stuff.
What's going on here? I thought I was here for an interview. When I was a kid, I was probably first exposed to science through science fiction, through Star Trek, but also through comic books, and I think that inspired my imagination.
Ever since Alice in Wonderland, writers have been fascinated by the idea that ours may not be the only version of reality. They still are.
Other worlds and alternate realities are really a staple of science fiction. You see it everywhere, the notion that there's more out there than meets the eye.
Look at the magnificence. No one on Earth has seen such a sight.
But are the parallel universes of science anything like the sci-fi ones?
The ones that we have discovered are actually far grander, far more exotic, and far wilder. There are many more possibilities than they've ever considered in fiction.
Oh, really? Just how wild are the parallel universes of the scientific kind? Meet Max Tegmark. When it comes to parallel universes, you could say Max is pretty hardcore.
To me, these parallel universes aren't just some cutesy idea that's fun to chat about to provoke my colleagues. I really believe that this is how reality works.
Max and his fellow scientific believers argue there are effectively 3 different types of parallel universe. Some exist far beyond the furthest edge of our visible universe. Others hang out in a mysterious landscape full of dark energy called the multiverse. And others are right here in the same space we are all living, but we can't see them, obviously. It's thought we can't travel to any of these other universes. But there are so many versions of reality, you don't need to travel. In many, there's already an identical version of you there, and he thinks he's you.
If you have 2 different universes and both of them have a Max Tegmark in them, that other Max is going to feel that he is the one and that his thing is real. It's completely symmetric. The only catch is the 2 can't communicate with each other.
And maybe that's a good thing, because you might not want to meet your other self.
In this particular universe, I'm just here because this location and this funky warehouse will help me explain parallel universes. But that's no more real than another parallel universe where I'm a detective looking to see where a serial killer might have buried a body. And then another universe where I am the serial killer trying to figure out where to bury the body. Or a parallel universe where I am the dead body. All of these parallel universes are just as real as this one.
In the latest thinking, there may even be universes where your memories and dreams are playing out for real. How on earth did science come to believe such strange ideas? The first time it was suggested, there was outrage and scandal. In the 1870s, a craze swept across Europe and North America. Psychics performed for the public and spoke, they claimed, to people who lived in other versions of reality. other worlds.
In the latter part of the 19th century, people were fascinated by the idea of extra dimensions and alternate universes, and lots of people preyed on that fascination.
Talk to us. We're ready to commune with you.
Top scientists and thinkers speculated these worlds must be parallel universes.
When physicists in the late 1800s were dabbling in supernatural and paranormal, I think some of them really thought they were onto something.
One of the most eminent scientists of the day was Sir William Crookes. In his serious scientific work, he explored how the new invisible force of electricity could make metal objects radiate and even move, as if by magic. But Crookes's other passion was the paranormal. He defended the psychics publicly and even took his own photographs of ghosts he said they'd conjured up. When the mediums were exposed as frauds, Crookes's reputation was almost ruined, and all discussion of parallel universes and other realities became scientific heresy.
After this backlash, people really didn't want to touch with a 10-foot pole anything that was considered weird or too philosophical.
Scientists wanted to dissociate themselves with all of that nonsense.
Parallel universes, though, would make a comeback. And this time, they'd be just as weird as ghosts.
That same scientific community has been pulled kicking and screaming to embrace things that were even stranger than those 19th century occultists were thinking about.
The modern parallel universes of science emerged from a revolution, one that overwhelmed the classical physics of the late 19th century, when science was dominated by the practical common sense of engineers.
The spirit of classical physics is pretty much reflected on the architecture of the time. For example, Grand Central in New York City, or many other buildings around. They are orderly, elegant, very solid, just like classical physics.
The physics at the time seemed to describe a world that's ordered, where trains arrive on time, everything's in its place.
Physicists viewed the universe as a kind of a clockwork machine. There were particles that had definite positions that moved in definite ways, and that if we understood how these particles moved around, we would understand everything.
At the heart of this confident scientific vision was a belief that the universe was made up of two very different phenomena.
In classical physics, the world makes common sense. Matter's made of particles. They're solid. They follow simple trajectories. You can calculate their motion, their speed, their angle, their velocity at any time. But most important, they're always in a single place in a single time. And then there are waves. Waves are in some sense the opposite of particles. They're extended objects. They're not localized in space. At any one time, there's motion taking place at many different points in space.
If there was one thing that classical physicists knew for sure was a wave, it was light. Or they did, until the arrival of a young upstart. In the early 1900s, Albert Einstein was spending a lot of his leisure time doing two things: practicing on his violin and trying to understand the strange results from a new experiment which had just been run in Germany. At the time, he was a scientific nobody, and the experiment was being run by one of the grandest old names in German physics, Philipp Lenard. Leonard wanted to explore the nature of light. He took equipment, invented by that old lover of the paranormal, Sir William Crookes, and devised one of the most important experiments in the history of science. He shone bright beams of light onto a small metal plate and measured how much electricity was produced. Since he assumed light was made up of continuous waves, he thought the more he increased the brightness, the more current he'd get.
This seems like it ought to be something really simple to explain, that you have a light wave coming in and that wave shakes the electrons around and knocks some of them loose. But if you get into the details of it, the wave theory fails really miserably.
People expected the brighter the light you shine, the more current you would get. They found that the amount of current for the amount of light that was shown on it just didn't make any sense.
It all made sense to a certain amateur violinist.
Then Einstein comes along and manages to explain all of these measurements beautifully.
He showed that you couldn't understand it if light was only waves, but if light also acted like particles, small lumps, then you can understand how when each lump hit the metal surface, it knocked out electrons. And those lumps became dubbed quanta.
Einstein had unleashed quantum mechanics, a scientific revolution that would lead directly to parallel universes. The new theory described the physical world around us in a disturbing new way, down at the subatomic level.
Quantum mechanics really battered classical physics, saying each bit of that classical edifice doesn't really work. This beautiful conception that they had going into the 20th century became fragmented and incredibly difficult to understand.
The quantum world is different. It makes no sense.
It's not just that light can be both a wave and a particle at the same time. The opposite's true. All the particles that make up matter are also waves, and they can be doing many different things at the one time. They can appear from nowhere and disappear without warning.
It seems sort of like something somebody would make up just for fun. Let's think of the weirdest thing we could possibly think of, and then let's teach that in physics class.
So is there anyone who isn't fazed by quantum mechanics? Meet Emmy. Her owner, physicist Chad Ortzel, grew tired of trying to explain the weirdness of the theory to his students. Finally, he told them, just think like a dog.
Humans find it really strange because we come to the theory with a lot of preconceptions about what ought to be happening in various situations, and dogs don't look at the world the same way. Dogs are surprised and amazed by everything that they find. They approach the world as a constant source of wonder.
In everyday life, if you throw a ball, it goes in one direction and ends up in one place. In quantum mechanics, if you fire a particle, it can go both left and right and end up in two places.
Emmy, would like very much to be able to run at a tree and go around both the left side and the right side at the same time. And that's the situation that quantum particles are in. One of the most important things that I learned from thinking about this stuff like a dog is that if you just accept the strange parts of the theory and sort of roll with them, it leads to a lot of really wonderful things.
Scientists know this strange theory is right for a very good reason. Quantum mechanics is mysterious, but the practical effects are all around us.
Quantum theory is incredibly abstract and it's often very hard to believe. But in fact, nowadays, it really is crucially important to the technology that we rely on every day.
Because we know about the wave nature of electrons, that allows us to make computer chips that are the basis of pretty much any interesting device that people have today. the internet, the cameras and cell phones that people carry around with them are entirely based on our understanding of quantum mechanics.
And how does this lead to parallel universes, you may ask? It's all to do with those pesky waves and particles. But let Lawrence Krauss explain.
The quantum universe is far stranger than the classical universe. In fact, in the quantum universe, all classical notions of common sense go out the window. The distinction between particles and waves becomes blurred. In fact, particles can begin to act like waves, and waves like particles. It's confusing.
So we ended up in this sort of schizophrenic situation where everything that's real is both a wave and a particle at the same time.
And even more remarkable, particles can be in many different places at the same time.
How can something be in more than one place at one time? This bizarre conclusion is driven by some quantum logic. All the matter that makes up our universe is made up of particles. Waves, though, have no single location. So if all particles are also waves, well, you can see where this is leading.
You can't really say a particle is in one place or another. A particle can really be in two places at the same time.
It may not seem like such an important thing whether a particle is more like a particle or more like a wave, but it really undermines our whole conception of what it means for a thing to be here rather than there.
We know from experiment that particles can be in several places at once. But hey, you know, I'm made of particles. So if these particles can be in several places at once, so can I.
From this seemingly innocent thought, parallel universes were finally born. For if the stuff, the particles that make up reality, can be in lots of different places, then that suggests many different versions of reality with different histories.
History is the ultimate example of how the future of what's going to unfold depends on the tiniest little events, even quantum events.
I think it's remarkable how microscopic events can be amplified into changing the course of history. If the particular sperm that was Hitler's had not come first out of the millions and millions when he was conceived, the Second World War might not have happened in the first place. On the other hand, if some neurons in Hitler's brain had been behaving a little bit differently, maybe he would have listened more to advice from his generals and maybe would have won the war.
Just a few small quantum changes, and what's now New York is a vast Aztec city. The American Civil War was a battle over European slaves. And the Cuban Missile Crisis didn't end happily. Quantum mechanics implied these outcomes were every bit as real as ours. But there was a mystery. If there are lots of versions of reality, why do we only ever see one big world around us?
The early quantum pioneers were really weirded out by the fact that big things seemed to be in only one place, even though the things that they were made of, the particles, were allowed to be in several places at once.
How can we go from particles that can be in many places at once to actually pinning down just one place?
There was a sort of consensus that we should just solve this by brushing it under the rug.
No one would really take the idea of parallel universes seriously until someone solved that mystery. It would take an extraordinary scientific rebel to do it. In 1971, Hugh Everett is being chased around Los Angeles airport for randomly taking photographs of the Secret Service. Everett's behaviour has become increasingly eccentric ever since he proved how parallel universes could be real.
Hugh Everett was a man of brilliance and also a man of contradictions.
Hugh Everett's discovery was as big a breakthrough as those of Newton and Einstein.
As a student, Everett wrote what's become the definitive argument for parallel universes, called many worlds. Unfortunately, his theory was thought to be so crazy, it ruined his academic career.
He left physics, did a bunch of stuff for the military, and got quite bitter. Smoked and drank way too much and died of a heart attack at a quite young age. Some sad end.
Everett asked a simple question. Why is it that if every version of subatomic reality exists, we only ever see one world around us?
His insight to solving that problem was absolutely brilliant.
The simplest interpretation of quantum mechanics is the Everett interpretation.
Everett's answer was that effectively, every time we interact with, observe, or measure the world around us, we cause the universe to split. And ourselves. Weird? Yes.
It's hard to picture Everett's interpretation of quantum reality, so I'm trying to do it here with 8 people and 4 green balls. Each of these balls represents a different position and trajectory of a single quantum mechanical particle that's in many places at the same time. But when I make a measurement, I fix its position. I've split the universe. This is my reality. All the other universes still exist, and they're just as real as mine, but I'll never experience them.
Is he making this up? Apparently not.
Anything that you do that has 2 possible outcomes, the universe splits, and in each of those, everything is duplicated. Right? There is a you in that universe that sees one outcome, and there's a you in another universe that sees the other outcome.
This type of thinking sounds spooky. How can it be more than one world? How can the same person be doing different things in different worlds?
But how does such a weird idea work in practice? Even surprisingly small events can split the universe.
If we choose a person to walk the streets of this city, that person has to make a choice whether he should take the right street or the left street. Every time that person makes a choice, then we have created a different reality.
Suppose, for example, I go to get a coffee at a coffee shop. I may be torn as to whether to get a cappuccino or a latte. Then there is a version of me that gets a cappuccino, and there is another equally real version of me that gets a latte. So both drinks get consumed, although nobody gets to have both drinks.
And every time the universe splits, the changes multiply. In, say, one version of reality, Lawrence Krauss is fired on by a sniper.
So in one universe, I'm a goner. But in another universe, the bullet just misses me and I run like hell. The universe is split. In one, I'm alive, and in another, I'm dead. And then when I spot a gun on the floor, it splits again as I decide whether to seek revenge or keep running. And the universe will keep splitting again and again to infinity. No bullets.
It's easy to imagine that all these scenarios are just for fun, but the theory applies even to the most important events. Like the one that happened one sunny September morning.
One thinks about an historical event such as 9/11. Any variation of 9/11 which is consistent with the laws of physics, we would expect to occur.
Ultimately, what one atom does can affect whether 9/11 happens or not.
In the universe we live in, the men behind 9/11 managed to avoid detection. But for scientists who believe in parallel universes, there are many other real worlds where the men were caught. In some, their plans were discovered at an early stage.
There may have been an analyst at the CIA who uncovered some conspiracy.
In others, their names were on a warning list. And in yet other versions of reality, the terror plans unraveled at the last moment.
If just one atom in the brain of one of the security people would have been in a slightly different place in a synaptic junction, that might have been the difference that would have caused him to decide to do a spot check on that one person going through security.
There are people alive in that universe that aren't alive in our universe.
The same men who are perpetrators in our universe, in others, are just ordinary tourists. And instead, young Christian extremists are the plotters.
And there are also universes which are far worse, where, for example, the fourth plane made it all the way and crashed into the White House.
There are even real worlds where the terrorists were carrying nuclear material. In these versions of reality, the nation's financial capital has to be abandoned. And Grand Central is controlled by vigilantes.
Anything that's physically possible would be expected to happen somewhere.
Those aren't all could-haves, they're actually out there, they happened.
It's strange enough that scientists can now imagine an infinite number of other realities. Just as strange as their location. The parallel universes of the many worlds theory are laid over us in the same time and space we inhabit. But they're not the only parallel universes. Another theory suggests just as many other realities. And these lie out beyond the stars. Very far away, past the edge of our visible universe, there's a planet with 7 billion people on it. A planet that's a carbon copy of ours. And it's not the only one.
There would be a number of Earths exactly like our Earth, and exactly like various other possible Earths that one can imagine.
There will be exact replicas out there. You are guaranteed to find matter arranged in just the same way.
On these Earths, there would be exact copies of each of us, down to the last molecule. And if one day someone invents a way to travel much, much faster than the speed of light, we could even meet them. This eerie conclusion emerges out of the work done by this man. For years, Alan Guth has been quietly, calmly studying the biggest, most violent cataclysm ever. The Big Bang, the moment our own universe was born, when temperatures reached unbelievably high levels and all the energy to make our universe erupted from a single explosion. Alan wrote the most convincing and detailed description of the event. And he did it with the help of bubbles. He suggests that for a very brief period, just after the Big Bang, the early universe inflated super fast, like a bubble. In that brief moment of inflation, the building blocks of our universe were formed. And when we say brief, we mean really brief.
This period of inflation could have been extraordinarily short, about a trillionth of a trillionth of a trillionth of a second. And that's a decimal point followed by 35 zeros and then a 1.
It was this super brief bubble that went on to form the universe we can see around us. And how does that create other realities? It turns out that what we can see is probably a tiny part of the real universe.
We can only observe a certain amount of the universe. Light takes a certain amount of time to get to us, and in that time it can only have gotten a certain distance. That's everything that we can see, and it's a particular size. But why would inflation blow up the universe to just that size? Why not, say, somewhat bigger?
Many scientists now believe that far beyond the limits of the universe we can see, a much bigger, invisible universe continues.
We have no way of knowing how big the universe is. As far as we can look, the universe just seems to keep on going. So one possibility is that the universe never ends. It might be infinite out there.
If our universe is infinitely big, then a curious logic kicks in.
We and the Earth together are made up of particles. These particles are put together more or less like Tinker Toys attached to each other. There's presumably only a finite number of different ways these particles could be put together to build something like a planet like Earth.
In an infinitely sized universe, these finite arrangements of atoms and molecules would eventually repeat, making near copies of us, and then eventually identical copies.
And eventually they'd run out of possibilities, and the same old possibilities would have to repeat. And if the universe were literally infinite, there would have to be an infinite number of copies of everything.
If our universe is infinitely large, then somewhere out there has to be another accumulation of atoms that looks just like the Earth, that has a being on it that looks just like me, who has a dog who looks just like Emmy. Everything that we see around us has to be duplicated.
In these copies of our own world, the other people who look like you think they are you. They'll have your internal thoughts, your memories. But these aren't the only physical copies of you lurking somewhere out there. Inflation explains some of the mysteries of the Big Bang. But for many physicists, including Laura Mersini-Houghton, there was another obvious burning question. What caused the Big Bang in the first place? Many scientists now argue the energy to create the Big Bang must have existed before our universe began.
Okay guys, let's move this thing now.
In a time and space they call the multiverse.
Throw the balls!
No one's sure what the multiverse looks like, so Laura's built a model for us.
This is a way to visualize the multiverse. All the hills and the valleys represent the energy distribution in the multiverse. And the balls represent the potential initial universes that can grow and look like ours.
Unlike this plastic sheet, the real multiverse is infinitely large. And instead of rubber balls, it's full of an infinite number of universes. It's a bizarrely strange place that scientists are still struggling to imagine. Some think it may even look a bit like this, where each one of these stretched bubbles represents a universe as large and complex as ours. And each hole represents the moment of a Big Bang. But in truth, everything about it is unfamiliar.
We certainly do not have a very clear idea of what this multiverse that we talk about might look like. It would certainly be a very twisted space. According to general relativity, space itself can twist so that space and time can become intertwined in complicated ways which are hard to describe.
We don't know whether those other worlds, those other universes outside our own, if they are even part of the same space-time as our universe. Some of them might have different dimensions. Instead of volume, height, and length, they may have a fourth dimension and a fifth dimension.
The kind of particles that would exist in one bubble universe could be completely different from the kinds of particles that would exist in another bubble universe.
The entire multiverse, it's thought, is fueled by a mysterious type of energy, one that astronomers first detected in our own universe.
Our universe today is accelerating. If that's true, there has to be something driving that acceleration. We call it dark energy without knowing exactly what it is.
It's now thought that most of the energy in our universe is dark energy. And in the multiverse, it may be the driving force constantly creating new universes.
All the valleys in this landscape of energy have the potential to give birth to a universe.
We used to think the Big Bang was a huge event. But in the multiverse, Big Bangs are probably happening all the time. The birth of our universe could have been just a tiny, almost insignificant event, as our universe joined a countless multitude of other universes.
Some of them look like our universe, some others don't, but the main point is that there is nothing special about our universe since there are so many other universes.
If we look around in the world of science and ask what kinds of things does science know how to talk about, of which there are only one, there's really nothing that science talks about of which there's only one, except maybe the universe. But why should the universe be an exception?
This process, creating these bubbling universes, goes on forever, and so it creates an infinite number of these bubbles.
Okay, guys, thank you. Stop.
If the multiverse creates an infinite number of bubble universes, then the same patterns that make up the matter in our bodies and on our planet will get repeated all over again. Your life is being relived right now, somewhere else in the multiverse. But it's not as if we could ever sense the existence of these other universes. Could we? In 2001, NASA sent a satellite into space. Called WMAP, it aimed to measure the radiation that had been left over since the Big Bang. It may have found something else as well. When the signals were processed, the resulting map showed an area like a hole where galaxies had accelerated away from. Some said it was as if part of the universe was being pulled. What no one knew at the time was that Laura Mersini-Houghton had made a controversial prediction that other universes might exert a gravitational pull on our own.
One of the effects that I predicted as a signature of this theory was a sliding of all the galaxies and stars in the universe. It's like a tilting of the universe that would come about from the interaction between our universe and all those other worlds outside our visible universe.
When Laura was sent the images from WMAP, she was convinced her prediction had been proved right. Other universes were tugging on our own.
I called the team leader at NASA, and I discovered that the NASA team had no idea of the theoretical work and the predictions that I'd been making on the last few years. So the two, experiment and theory, were up to that point completely independent of each other. And of course we were both excited.
Laura's theory remains controversial. Other scientists argue the effect might be caused by some as yet unknown force. But if she's right, we could be on the brink of a historic discovery.
Perhaps we can never travel beyond the edge of our universe, but we are basically seeing the effect of other universes on our own. And once that experimental finding is confirmed, then we know for sure that there are other domains and worlds beyond the edge of our universe.
It may not just be signals that could come out of the depths of the multiverse. Something much more dangerous might be headed our way. It's all to do with the nature of those bubble universes.
So our universe may just be part of this big, tangled web of bubbles, floating, combining, continually being created.
Scientists like Anthony Aguirre have realized that some of these bubbles can form within existing universes.
If another bubble were to form inside our bubble universe, that would be bad news. Unlike these bubbles, the bubble would expand with the speed of light, essentially wiping out everything in its path, including us.
And even more strangely, bubble universes, it seems, move. And if they move, they can collide. Parallel universes might even be the cause of the ultimate disaster.
If one of these bubble walls was headed for us, it would be traveling basically at the speed of light. So it would look like a huge expanding mirror that would come and unfortunately convert us into whatever the new bubble was made out of. So we basically would be torn into little bits, and the physics that we know and love that makes us work wouldn't even apply.
If we don't actually get destroyed by a parallel universe colliding with us, what then? Is there any other practical way that parallel universes could change our lives? Physicists disagree.
A copy of me in another universe with a very different history would be no more similar to me than someone with superficially similar characteristics on the other side of the planet. And so ultimately, I don't think it makes that much difference in terms of how I live my life or what I'm going to decide to do.
For others, though, the idea that there are infinite versions of our own lives is strangely appealing.
I don't have to think of myself as isolated and just here, but I've got all these brothers out there, all these copies of me as one spread throughout the universe. I'm everywhere in this strange sense.
It makes me take myself much less seriously, first of all, because in the grand scheme of things, you know, my little problems aren't such a big issue. And it also, I think, takes the pressure off from having to get things right all the time when I know that there are all these other Maxes which are succeeding where I fail and failing where I succeed.
Some of the implications of parallel universes can even sound mystical.
If the universe is infinite in time, then every experience any one of us has ever had will happen over and over again an infinite number of times. And depending upon whether you're an optimist or pessimist, that's a good thing or a bad thing.
Even if someone takes a whole bunch of crazy risks that are almost certain to result in death, there will always be some version of them that survives and goes on. No matter how many such events happen, someone will miraculously, time after time, escape that. So, in some sense, we're all guaranteed in this strange way immortality. An exact copy of us, identical to us now in every way, will go on living essentially forever.
Eternal life. Infinite realities. Science has been taken on a strange journey. But if we really do live in a parallel universe, that strange journey may only just have begun.